it. So I shall introduce you to Nigel Paine, who's going to give us a talk on the design, prototyping, and production of a Fox pattern 8-foot bogey. Is that a correct introduction, do you think, Nigel?
I think so, yes.
So
Good
anyway,
morning.
it's over to you.
I think that's okay, David. Good afternoon, everybody. You've joined me in the afternoon time now. Greetings from Slovakia. We have blue skies and a very, very sunny day, and I've had to pull the blinds down and control the lighting, so hopefully you can see me okay. Fox pattern bogies. Why? Nigel says. About 3 years ago, just around COVID time, I started a project to build a rake of five Northeastern Railway clerestory coaches. I'm sure I did a presentation about that on a virtual show. But this was a Poppies coach. Here's one I prepared earlier. So it'll fit in the screen. It's a Poppies, one of the Poppies design coaches, and the body is the kit. Unfortunately, there's no underframe, which I've had to create, and there were no bogies. So I wanted some Fox pattern bogies, and I made a few interesting discoveries about that. I did a bit of research about Samson Fox, I think his name was, not Samantha, Samson. I'll just relay this to you. This is about Samson Fox and his idea for bogies. He was born in Bowling in Bradford in 1838. So Bradford, not that far away from the Keighley Club, where I got all my inspiration for becoming a Northeastern fan. Samson Fox worked in a textile mill, of all things. Started work at the age of 10, apprenticed as toolmaking, and started to work in a foundry company. In his 20s, he was running a toolmaking company called Silver Cross Works. A bit of checking on that, a bit fact checking and things, and it's not Silver Cross Pram Company. That's up in Wetherby, I think they are, not Wetherby. Baildon. In 1874, he set up a company called the Leeds Forge Company, where he started designing a corrugated boiler flue. And in 1887, this is where we come in, a forge pressed steel bogie design. So Leeds Forge, I'm trying to work this out. I don't think it's to do with the Kirkstall Forge, which obviously is just outside Leeds, which I think is one of the oldest engineering locations in the UK, sort of goes right back to the beginning of the Industrial Revolution. But nevertheless, 1874, he decided that he would design a forged pressed steel bogie design. If you look at for example, well, most railway bogies, they tend to be an assembly riveted together. Whereas with this design, is the main side of the bogie is actually pressing. They could support 120 tons without failure, and they even came with a guarantee, even back in those days, 5-year guarantee for your bogies. It didn't really have a huge amount of interest in the UK, other than the Northeastern Railway. And he travelled with his product to the USA and founded the Fox Solid Pressed Steel Company in 1889, where the bogies were sold in kit form, with railway companies adding their own accessories such as axle boxes, brake gear, footboards, etc. So yeah, the bogies probably, in America, they're probably more prevalent than they are in the UK. There are a few companies that have them. I had a discussion with Robin Taylor about this, and he said sort of South Wales. In South Wales, they have a few. But one company that went with them full on was the Northeastern Railway. So that's why I decided that I needed to make some proper bogies for these coaches. I think a little bit funny for running under Great Western, some bogies. Finishing off on Fox, he developed a gas lighting system in Harrogate, one of the first towns in the country to have street lighting. And he also donated £45,000 or 4.5 million in today's money to form, is one of the founders of the Royal College of Music. Quite an interesting guy, this Samson Fox. Oh, one of his descendants is the Edward Fox. So that's quite interesting. Right, so I decided that I should build some Fox pattern bogies. I did look at the market and to see what was there. There were some, granted. I would say that some of the samples that I purchased, they were lacking. Some of them looked like a melted bar of chocolate. Some of them were reinforced by an etched brass or nickel silver framing. My friend Dougie, our friend Dougie in New Zealand, Mr. Hay, I don't know if he's watching. If he is, greetings, Dougie. Dougie made some Fox pattern bogies. I think they were derived from an original design by Cavalier. Cavalier had some lovely bogies. The axle boxes bear no resemblance to the Northeastern design, though. So Dougie remodeled those so that they were Northeastern design. Unfortunately, the molds that he had were getting quite old when I came to him, and they were, as he termed it, getting a bit snotty. So if we can see, can you see that? You see that? Right, there's a lot of reflection there, isn't it? Right, the bogies are a bit snotty, and what that means is that the casting wasn't particularly good. And bear in mind that I'm building 5 coaches. That's 10 bogies. There was a bloody lot of work to do to get these bogies working. But these weren't a bad representation. But moving forward during the COVID period, I relearned CAD and using Fusion 360, and I thought, well, maybe I can design my own bogie, remodel it, bring it up to date, and try to create a decent bogie for my requirements. I'd also, lucky me, running a business, we decided that we might want to buy a 3D printer. So in learning about CAD, I also had a 3D printer, which we purchased through the business. Nothing special. It was a Elegoo Mars. I think they're about 300 and something pounds. Really, really, really good piece of kit. Really impressive. So it could churn out nice, accurate things like this. Here's a preview. You know, there's nice, accurate bits of resin printed things. Not very strong. I could snap that quite easily, and it wouldn't run around a layout for very long, especially if it was running around something like Raven spec non-stop. The bogie would fall apart. Moving forward from that, if you've got a mold, then if you've got a master, then you could always go to somebody and ask him to make you some to make a mold and to print them out, cast them rather themselves, and that's quite good for things like getting I don't know, lost wax castings made, of which I have some on this model here. But if you're getting bogies made, it's probably better to do them in white metal, as most of them are. And so I decided that really I need to either find somebody who could cast these for me in white metal or do it myself. Again, I did it through our business, but to a certain degree, there's no reason why you couldn't do it yourself if you've got a bit of money to spare. If you can afford to go and buy yourself a one of these beautiful, I don't know, Western locomotives or all of these ready-to-run brass things that you can see running around these days, you could afford to go and buy yourself a 3D printer and a casting machine. So I've decided that I'm going to design, 3D print, mold, cast, and make my own bogies. And if you can't get a component that you want on your model railway, then maybe that's the way to go. I mean, I've got quite a few things that I want to make of my own. So, you know, investing in this sort of equipment was quite sensible for me. But I'll run through what I did, and you will realize, at least I hope you'll realize, that even a complete amateur like me could actually do this, make this. I'm not a professional model maker. I'm not an Andy Duncan. I'm not not even a David Smith. Bless you. You know, I am a amateur modeler, and okay, I like to make my models so that they look the right. So it takes me a little bit longer than most people, but in order to do that, you need to be able to design your own thing. So if I can I share, David?
You can.
I will firstly just run through a few pictures of the bogie. If I go to here, is that right? And I share.
Yep.
There we go.
There we go.
Right. So Fox pattern bogies. There we go, gents. So this is a Fox pattern bogie. If I wave my cursor around, can you see that on your screen?
NER.
NER, right. So that it's quite appropriate, really. That just proves that it is a Northeastern Railway Fox pattern bogie. Interesting design. You can see the pressed steel. You can see how the steel's been formed over, so it's like a corrugation, shall we say. Must give it a lot of strength and not be very heavy. So it's quite an interesting design. I just looked at the design of the bogie and decided how I was going to make it. I basically based it on how Dougie assembles his. So there's the main longitudinal. There's the axle boxes and the springs and the spring hangers here. Those were going to be one part. This middle section here with some suspension pieces and spring work, that was going to be the second. There was going to be a cross member, a cross member for the brakes that you can see here, and also another cross member at each end for which would also incorporate the brakes. So there would be, let's count that, there would be 1, 2, 3, 4, 5, 6 components in the 8 components, I beg your pardon, in the kit, if you want to call it a kit, plus an option on running boards, which typically the Northeastern Railway, you can see on this image here, is that there's a bracket, but there's no running boards. And these running boards would go through what looks like the center of the axle boxes. Depending on what part of the Northeastern Railway they were running on, they would either be above the axle box, through the middle of the axle box, on the bottom, or sometimes, because it's quite useful to be able to take the axle box cover off, they actually cut the footboard out at that point there. So that's the one part of producing this model that I had to decide what's best to do, and I've done it as a separate item, and you can, or I can add them as and when I want to. There's an illustration of the of a coach with the bogies on. if you are a studier of your bogies, these look totally different to any other bogie that you see running on the railway system. They're not a Gresley bogie, for example. And if you look at this image here, which is a very popular coach, in its LNER days and in preservation, as you can see it at the National Rail Museum, I should have incorporated a photo of it. You will see that it is actually running under Gresley bogies, but these are Fox pattern bogies. So you can see that there is a difference. And a bit of detail there from both of them, you will see that the actual wheel that they are running, that these bogies are running under, the wheels are totally different to anything else that you see on the railway as well. These are Kitson wheels. Traditionally, and certainly all my much older Northeastern coach models, not that I've got many of them, but my older ones, all run under Mansell wheels. A Mansell wheel basically has got the center part of the wheel is made up of a series of wooden blocks. The Kitson wheel is the same, except the wooden block is hidden behind if you can see my cursor, behind a steel flange. And so the wheels are cushioned in the same way as the Mansell ones are, but the wood is more retained within the body of the wheel. It's not, and certainly with the body of the flange of the wheel. It might be easier to show you. Oh, I'll skip on one. Get back. This is a Kitson wheel, not Mansell. So the center bit here with all the squiggles is the wooden block. You can see that there is a little space there, which actually acts as the cushion on the tire. A quite clever design, but it is, if you're building a model and you want to do it properly, as I thought I would. Can I go back? I would I'd do it right. So I'm making my models with Kitson wheels. This, I think, if you're going to design something yourself, so this presentation isn't just about making a bogie. It's about how you research and how you make your own items. This is probably the most essential thing that you want to find a drawing of the item that you want to make, and some photos. So I've shown you some photos. You can see them. So then you can look and see how the thing is constructed. And you can also see here some useful dimensions. When I designed this in Fusion 360, I think I can have a look at that. I can fire up Fusion 360 and take a look and see what I did. But I'm pretty sure I imported this drawing as I think the term they use is canvas. But we'll go back to me, shall we? Oh, well, you can see the design of the bogie. There's 3 springs here. Oh, you can only see 2 at the front. You've got a dimension. You can see there that is 8-foot centers. So it's an 8-foot Fox bogie. Along the top of here, you can see a series of rivets, which are quite nice. Oh, you could feature them in a model, couldn't you? So yeah, you could do that.
Nigel, could you go back to the original photo, the first photo of the coach? Yeah. Now what's that? Oh, hang on. No, next photo. What's that looks like a third wheel?
Well, this is the Northeastern Railway dynamometer car.
So it is a third wheel. It is it's a fifth
It is
wheel, actually, isn't it?
It is effectively a third wheel.
Yeah.
This is quite an interesting vehicle. We divert a bit on this, but this vehicle in LNER days was the vehicle that ran behind Mallard when it broke its record. So it's got a lot of history. and it sits in the National Railway Museum. It's got like you call it the third wheel. It's got an extra wheel which could be raised and lowered onto the track bed, and
Yeah.
that is where they actually get the readings of the speed of the of the train. It's got this funny window here as well, which is quite a challenging design. It's got some interesting curves and things. Mr. Lovelace made a very, very nice model of this dynamometer car, but it's an LNER one with Gresley bogies. So I've got one, but it needs modifying. Also, this vehicle in northeastern days didn't have a corridor connection, as you can see in this photo. If you look at it in the National Rail Museum in its teaked finish, it's got a corridor connection. So if I'm going to make mine into a northeastern vehicle, there's quite a bit of modification required, including bogies, which, guess what, I can do. Yeah, and the final interesting thing about this vehicle is that this side here has got some, shall we call it, streamlining. It's got a bay window that sticks out, and so you can look and see where you're going. The other end of it, at the back end of the coach here, is it's flat, so it only really goes in one direction. So as we see it here on the right hand side, the locomotive would couple up to the coach. Yeah. Any questions while we're at this point?
Yeah, I presume that dynamometer wheel, would it be a single wheel, or it's not an axle, is it? That's not a wheel set.
I think it's a single wheel.
Yeah, it would be presumably geared up by whatever means to the recording instruments in the
exactly.
in the
Yeah.
thing, which they wouldn't be
Yeah.
able to do off the real bogie, would they?
They wouldn't be able to do it off the real bogie. Probably nowadays they probably put some sort of electric device on it and
Mm.
dynamo or something, and they'll be able to get everything. But that's how they did it in those days, or certainly how the Northeastern did it. I don't think that anybody else on the LNER group of companies actually had a dynamometer car. I think it was only the Northeastern. The Great Western had one, and the LNER and the LMS had one, I'm sure. But
Yeah, the LMS certainly had one.
so the LMS certainly had one.
Yeah.
This thing, if you visit it in the museum, if you go into if you're allowed inside, and we've got some cupboards with lots of recordings of various trials that were on it. So quite interesting what it actually was used with. I think it obviously ran with a lot of Northeastern locos. It ran with a Northeastern number 13, the electric loco. It Raven Pacific, and then it went on and ran with a lot of LNER locos. So obviously it did its thing with Mallard. And then in later years, it even ran with the Deltic prototype, my other pet hobby. And
Just had a note from Richard Clark to say that the Lancashire and Yorkshire also had one.
oh, right, there you are. Thank you, Richard. That's interesting. Yeah. But as built, as you can see there, it ran under Fox 8-foot Fox pattern bogies. So hence my desire to create my own version rather than the ones that I was using. How do I get out? Stop share, I think it says, but that's yeah, that should be okay. So these bogies, basically I started off with a drawing, which you've just seen, and a series of photographs. The dimensions were quite important. Let's see if I can go back to sharing, and if I can find what I'm looking for. I still haven't found what I'm looking for. Fusion. Here we go. Right. Can we see Fusion up here? Let's see if I can find the design.
We just have a banner which says comments at the moment.
just have a banner that says comments. Okay. Have I knew I should have prepared and got this ready. There we go, Fox Bogey. Come on. Can you see the bogey yet? Can you see anything on the screen yet or not?
No, no, still only comments. Ah, something's happening. Right.
Why does it say comments?
I think you need to stop sharing, put Fusion up, and then share again.
Aha. Let's try that. Thank you. Let's try that. So. Any luck?
Yeah, we can see that.
That's good. Okay, right. I guess you need to go to the very beginning, don't we? So, we'll give it the bit of the front. So bear in mind, gentlemen and ladies, if there are any here, I'm just running through this slowly. I never, beginning of COVID, I never worked with Fusion 360 CAD design at all. So I would, well, it's a bit of a lie. I did a little bit, but I was, but I had to reteach myself and relearn the whole process. But this is the first component that I drew up, which was a stretcher that runs across between the two side frames of the bogey. So the center hole that you can see here is the pivot for the model. This was based on the existing bogey that I had, and also that is based on the Cavalier, the original Cavalier design. It's quite strong because if I spin it around to, oh, come on, Paine, get it right. There we go. Right. You can look at it here. It's got some strength here, so it's not going to bend through the length. If you're sitting a coach on top, it's not going to bend. It's like a beam. I've decided that really we should make sure that if you're going to drop a bogey or drop a coach onto the track by mistake and it's a heavy coach, it's not going to bend. I think that's a fairly important part of the whole thing. I don't know what I'm doing now. Here we go. So now we decided that we're going to do the side of the coach. You'll notice that in the first thing, you don't need to draw both sides of it because they are a mirror image. So what I did is I did actually work on it on a just one side to get the whole thing going. Now, I will whiz through this because we could have a whole hour of just looking at things, but you can see how it's steadily evolving. Oh, there's an axle box. If you've got any questions, just step in and ask. I've rounded off the edges because this is a pressed steel bogey, so this is using a fillet function that you have on Fusion. Might be worth us whizzing forward somewhat. Let's see where we can go. So I've taken it right to the end of here. You've got a whole series of components in this model. If I switch them all off, we can go through them. So we started with the bogey pivot, which we've already discussed. See if we can, yeah. It has the words 35.5 millimeters written on there to remind me that that distance between here and here is 35 millimeters. Because the way I've designed this is that it's a good representation of the wooden timber that runs across the bottom of the vehicle. So this is the this is the bit that actually attaches onto the coach. Let's find something. So now we've got the stretcher to which it attaches, which is the part, which is the bogie. You can see how that all fits together quite nicely. The bogie side, which as I tried to describe to you earlier on, is that what I did is I only designed one half of it. So where this blue line, this green line is, or blue line, green line, blue line. I designed only one side of it, and then when it was all finished, I created what they call a mirror. So it is exactly identical, except it's a mirror image of the original side. You will notice that I've actually incorporated the Northeastern Railway B, which is the axle box designation, and the journal designation for the coach. On top, you can see that I've included some rivets, lots of rivet detail, which just adds to the look of the coach. Because I could, I also included a lot of detail on the spring work here, which again, you just mirror it across, so it's exactly the same. Typical, as with everything, is that in later years, this is like a rubber bush, I think. It's a rubber bush, and in later years, it became an actual spring. So some later Northeastern Railway coaches will have had this spring feature. I think the first photograph that I included of the coach, bogie, you can see this spring work. Bogie side, the cross member. This is the end of the coach. Okay, and there will be a center spring assembly. Are you going to open up or not? What's going on? Oh. Why won't you open? All right. Looks like my Fusion 360 has decided to throw a wobbly, probably because we're multitasking. What you can see here is a basic design. From that, I think we'll move on. I think you've seen all of the main components. From that, using this application, when you've finished the design, you can export it as an STL file. But if you export it as the complete bogie, the STL file will be the complete bogie. So what I actually did was select one item, one component from the design, and exported that into an STL file. And from that, I could then start to import it into something called Chitu box. So if we just take that item there, and can we all see what's going on? It's probably going to throw a wobbly now and not want to allow you to see Chitu box. Can we see that? We can't see Chitterbox. David, somebody say, can you see a Grace?
It's still on stretcher, Nigel.
It's still on stretcher, is it?
Yeah,
right.
We're still on stretcher.
We'll stop sharing. Hello again, everybody.
Can I ask a question of everybody present? Does anybody else use Fusion 360?
Not yet, no.
I have done. I have.
I've actually downloaded it myself, but I've yet to actually
Yeah,
well,
so
pluck up the courage to use it,
I
I
use
suppose.
it all the time.
yeah,
I put a tutorial up on the guild pages about 3 years ago, so it's probably a bit out of date, but it was
Oh,
very
right,
good
Ian. Yeah,
just to get you started.
yeah.
There we go.
actually, and you're the culprit then, because I watched because I was deciding what I'd use, and I'm sure I watched your tutorial. So well done.
Oh, I did the first virtual show. I did a chimney or something, didn't I,
You did,
as well? Yeah,
yeah,
yeah.
yeah,
That was a while back. That was when that was about the fourth thing I'd actually done.
yeah.
So
Well, you
you
see,
get on.
you're like me then. You see, it's about the fourth thing that you've done, and again, it just proves to people that you don't need to be a professional engineer or a designer to be able to do these things. Fusion 360, just so everybody knows, can you can download a free version, and it has restrictions like you can't open up more than 10 designs at any one go. But generally speaking, if you're designing a chimney,
What
that's
would you
just
want?
one item. Yeah.
Hmm.
Paul
So
Crannett's asked, Nigel, if you have to make an allowance for shrinkage of the casting when you do the original shape.
depends on what metal you're casting in. Um, the advice I received from young Douglas in New Zealand, he did round field engineering, so he knows what he's or knew what he was doing, knows what he's doing. He doesn't really. Well, actually, that's a lie as well. He is making kits and producing kits still. I think for white metal, there isn't much shrinkage, and certainly when I've measured up my the cast results from the bogies that I've made, is that you can't see any difference. Brass, I think it's 6% you have to allow for. So
I've got Andy Duncan on the other screen. I'm actually watching two sessions at once.
right, ask,
I'll post a note on that one and ask Andy the question.
yeah,
What's the percentage shrinkage
but it depends on the metal. So ask him what percentage shrinkage is on white metal,
on white metal? Yeah, yeah.
or does he allow for it? But when I cast these bogies, is that actually there was I couldn't see anything, and if there was, if I can share again, and we can go into Jitterbox, which is here. Can we see that now? Thumbs up.
Yep, yep.
Yes.
Good. Right. So from there, we've just exported an STL file into. I've saved it. Christ, where would I've saved it? 3D print files. You can see I've done quite a lot of items here over the recently. All right, we can just import this thing called Fox Bogey Pivot. Ta-da! In it pops. And we'll just import a bogey side. In it pops. And a stretcher. There we go. So these basically all of those parts that I drew up within the Fusion 360, I exported each individual component separately as an STL file. And here we can see all of the items appearing as if by magic onto the Chitubox design. Oh, come on out. There we go. 3D printing, I'm sure that there's been a virtual presentation or certainly an evening with where somebody has spoken about 3D printing. There are all sorts of things that you need to understand about 3D printing. For example, finding the perfect angle to print the part, the component at. 45 degrees seems to be quite good if you're printing as fine as I am. I think it's 0.05 of a millimeter per pass. I think it's something like that. I'm not going to spend time going into the settings of it, but if you want to 3D, if you want to print something that's going to be a casting, you don't want it to be rough and ready. You want it to be as smooth as possible. So in this instance, we've drawn this up in Fusion 360 and exported it as this file. We can run through quickly all of the processes that I would do on this. Sorry, I have to keep moving this across because I don't know how to switch all of you gentlemen. No, what have I done now?
If you select full screen, Nigel, you might be able to.
Yeah, I've actually managed to hide you now, which is right.
Ah.
Can we all still see what
Yeah,
yeah, that's good.
And
Right,
so-
so there is a section on this which will allow you to, anybody who's seen any 3D printed parts, is they have this amazing scaffolding that you can see on the design. That's it. That's all I did is literally pressing a button. Let's just not select them all. Let's just select the bogey side. So
when you're designing these parts to fit together,
Yeah.
Nigel, what method do you use to actually fit them together on the, when you've printed the patterns out? Do they click together, or are they glued?
they right, well, okay, can I come back to that in the next 13 minutes?
Yeah, certainly.
Yeah.
Yeah.
Right, so here we have one component which has been drawn up, and it has been it's got the scaffolding to hold it. These are basically supports. Some consideration has to be made for corners and areas like that. If we enlarge this, you will notice that there's supports in various corners. That's reasonably okay. Sometimes if you don't have the corners supported, is when you start printing, is it basically just rounds it off because there's no way that the printer can support itself. So when the resin is exposed under UV light, it's exposed and then it just drops off, I think. So it's a little bit disappointing. But let's go back here, come back out. You can come back out. There we go. It's quite a large old thing, this. And the final part of this Chitu box system is called slice. And it runs through this program and it basically slices it into sections. And if I scroll down here, you can see on the left hand side in green, you can see the level that we're at. And on the right hand side, you can see that is what would be exposed on the model as it's being printed. And actually, this bit here, this part here, is the only usable part of the entire part of this scaffolding. All these little dots, this is just scaffolding. It seems to be incredibly wasteful, but if you look at it, at this on the right hand side, it's using 7.25 milliliters of resin, weighs 8 grams, and the cost of producing this component is 0.13546 of a, so 13.5p. So it's not bad. assuming that I have put in the latest costings for my for making this for buying the resin rather.
I've just had a reply back from Andy about shrinkage. He says he does not add anything as he only get 1% shrinkage, which is practically nothing.
There you go. Yeah.
But some people will add 2 to 3%, depending on how good the metal and the molds are. He then goes on to say the metal should be reasonably high tin content, as it is the lead that shrinks, not the tin.
There you go. Spoken by the expert.
Yep, there you go.
I probably would have found out about that if we'd gone to Google or to Mr. Duncan, but he is the expert. So yeah. The advice I was given for casting these was not to bother with any shrinkage adjustment on the white metal. There is a function here. We've just sliced that, but if we go back, there's a can you see there? There's a thing called scale. So basically, you could, if you open that, you could add a percentage. Right, so you could lock the ratio and you could add 6% if you're going to cast it in brass, and it would make it 6% bigger. So if I made that, is that right? I lock the ratio. Yeah, so we do want to. So if I make it 106%, I think that will do it on all three axes. Is that right? So that's 6% bigger.
Yeah.
So you could, so again, you could we'll go back into here and we can do the slicing. We can do that. We can do the slicing. Once it's sliced like that, and as you can see, we can. I think you can make this as a cartoon and speed it up, but we don't want to do that. This is the whole component which has been sliced. What that means is that if you look down the bottom here, it says layer height millimeters 0.05. So it's that 5 microns or 50 microns. I can never work it out. But it's 0.05 of a millimeter per layer that's exposed. Basically for each layer, it takes 2.5 seconds, during which the resin is exposed to basically it's like a little television screen at the bottom of the printer, which will expose, as we can see here, this area, which in the white, a bit further up, it's just exposing this area, and it's layer and layer and layer. And by the time we get to layer 1553, which for this component, it's quite big. It takes about 3.5 to 4 hours to print that. But when it's done, when you've sorry, I'll go back a bit. When you've sliced this, you save it. You save it onto a USB stick, and I can come back out of there. Stop share. I'm back. Can you see me again? Sun's moved and it's really bright and shiny on me. And when you have printed, when you've put it onto a USB stick, you go down to your friendly printer, which in my case is my Elegoo Mars printer. Oh, that sun's bright. Excuse me. With the wrong one, didn't I? That's a bit better. You can see me like a human being now. When you've it would print off and it will look something like that. So you've got all of these this scaffolding, as I said, but then on the top of it, you have the component of interest. In our case, we would have produced this, which is a 3D print of the Fusion 360 design, what I created. So that is the master for the next process, which will be making a mold and casting, which I would propose that we could return to that in a couple of hours and we could carry on. The casting process, I can talk through what I did. It was quite straightforward. And if we get time, I might even, we'll do it upstairs in the modelling room. I might even show you how I made that. Now that's something for you all to look forward to. Just to prove that it is possible.
Does anybody want to ask Nigel any questions about this, what we've just heard? Nigel will be continuing his presentation at 3 o'clock. That's 3 o'clock UK time. But if anybody wants to ask any quick questions now before we end this session. They've all gone quiet. You've stunned them all into silence.
Bored them to tears, I think is the term.
Well, I hope not.
Oh, I hope not. I mean,
Could I just ask, how long did it take you to actually do the drawing?
Good question. I should have a timer for this sort of thing, shouldn't I? It took quite a long time. Partly because I was learning how to, some of the components were a little bit tricky to make. So some of it is, shall we say, some of it is school time. But I would say, I'd say there's probably about 20 hours of work. But that's for all of the components to make the bogey. To draw up the, I don't know if you can see this here. This is the Kitson wheel insert, which you can see the sort of the Kitson wheel that was to draw up that probably took me about 15 minutes.
Oh, good, thanks.
So it's, I guess it's like learning to ride a bike. Once you've got experience with these things, you speed up. I don't know what you're thinking of making. I think that's the biggie. I had to draw up a oil lamp for something that I'm designing, which might have time to cover right at the very end, because I know at least one person here will be very interested in what it is. And to make that, it probably took me about 25 minutes, and it's got lots. I mean, I can show you the design, but it's
a lot of CAD packages, Noel. Sorry, Nigel. They do have a timer somewhere down the bottom of the screen, and it actually records the sort of session time. So if you're designing something over a period of several days or weeks, you can look and see exactly how many hours it's.
I guess if you're a professional doing this, you need to know what your hourly rate is, and that's a good idea. So I'll look at that. I'll come back to it at 3 o'clock, and I can tell you whether that's true. So I hope this sort of gives you some idea that you, if with the right equipment, you can actually start to make your own models, if that's what you need. I've really enjoyed designing this thing. I was going to show you something about the 3D print. I did take this to Guildford. I had it in my pocket at Guildford. I was quite pleased with that. This is the 3D printed bogey. And when it's all super glued together, and when I assembled it, everything slotted in together in a very satisfying fashion. Interference fit, I think, is the term.
Mm.
So that was something that was when I assembled this, I was really, really chuffed with it. It actually just all slid together as I had hoped. Yeah, I was pleased with that. Then, of course, the question is how will it cast, and how and there's it's casting is another
Well, that we shall see later. So, thanks, Nigel, for this morning, and thanks everybody for looking in. And we shall continue at 3 o'clock.
I hope
Thank
so.
you.
I hope to see you all later on, gentlemen.